Hello and welcome to my YouTube channel PHARMAVEN. In today's video, I will be discussing a brief about CIP cycle validation. Yes, when we say CIP cycle validation, it means cleaning in place. When we say cleaning in place, it means that the vessel which is going to be cleaned remains at the place. So we are not moving the vessel from one place to the area where the cleaning will happen. Cleaning will happen at the place where the vessel is kept. And normally this process is used for formulation vessel or mixing vessel, then the filtration vessel or sterile holding vessel, and if your filling machine is equipped with cleaning in place, then also into the filling machine. So let's begin, and I will request to watch full video to understand it better. So before we go for the CIP validation with product, we have to validate the CIP cycle as such. That means we have to ensure that the CIP cycle which we are performing cleans the vessel and the process piping completely. And how to ensure that? Let's understand. So to ensure that the CIP cycle is completely covering the entire surface within the formulation vessel, within the process piping, we have to do a test called Riboflavin coverage test. What is done in these tests? Let's understand. So in Riboflavin coverage test, we are preparing Riboflavin solution and it is sprayed inside the inner surface of the formulation vessels. Inner surface means all the walls, the upper dome, difficult to reach areas like view glass, like the material addition port, where it's very difficult for the spray water to reach. So in these areas, we have to especially ensure that we are spraying the Riboflavin. And once we have done, if you throw the UV light on that, you can see the green color fluorescence. So this green color fluorescence indicate that Riboflavin solution is there. You should allow it to dry, and after that, you perform CIP cycle. So CIP cycle basically covers a spray ball, involves a spray ball through which the entire surface within the manufacturing vessel or formulation vessel will be rinsed. And also it involves sometimes the recirculation within the vessel from the process piping so that entire vessel is completely cleaned. And once you do that, you have to check it again by using UV light that whether there are certain traces of Riboflavin or traces of the Riboflavin are completely removed or not. If you can see a green fluorescence at some places, it means that that part was not covered during your CIP. That means that spray ball within the CIP vessel, within the mixing vessel or within the formulation vessel is not covering that specific location. So to overcome that, you may have to have a different spray ball design, or you may have to add an additional spray ball, or you may have to put an additional nozzle to that specific location such that the all locations within the vessel are covered. So once you do this, once you do the Riboflavin coverage test and you ensure that the entire surface within the vessel is clean, all the process pipings are clean, that means your CIP cycle is now completely covering the inner surface of the vessel and the process piping. Once you do that, then you can go for cleaning validation with product. So how to do that? First, you take a product which you want to validate, and I will prepare a separate video on how to determine the worst case product. If you have more than one product in your company, then how to determine worst case product, I will prepare one more video about that. But to cover this, once you decide that I have to perform cleaning validation for this product, then you should manufacture the product. Once you empty out, once you filter it, and the entire production process, filtration process and filling process is complete, then you have to go for cleaning validation. And how to do that? You should allow certain dirty hold time. What we mean by dirty hold time? It means that in your day-to-day production, you will not be able to clean the vessel immediately after you complete your manufacturing. You may wait for 2 hours, 3 hours or a shift. In that case, what is the maximum time you have to wait, or you may have to hold the vessel without cleaning? You have to determine that time. For example, that time is 8 hours. Then 8 hours becomes your dirty hole time. So what you have to do? Once you finish your manufacturing part and your vessel is empty now, it has a product traces on the surface. So you have to keep that vessel for 8 hours and don't do anything, don't start cleaning. So within that 8 hours, what will happen? There will be some drying and the traces will become difficult to clean. After that, you perform the CIP cycle which you have validated through Riboflavin coverage test, and see that after that cycle, all the traces within the vessels, all the previous product traces within the vessels are removed. How to ensure that? How to check that? You have to do certain sampling. Sampling will be rinse sampling and the swab sampling. So what is the difference? Rinse sampling means once you have completed the cycle, you take certain amount of water for injection, or the water for injection, or the water which is used for the cleaning. Do rinse and collect sample and taste it for the presence of the product. And where we have to perform the swab sample, the areas where rinse sample is difficult, like for example the clamps, the nozzles, the needles, where it's not very easy to perform rinsing, then you have to do the swabbing from those areas where taking a rinse sample is difficult. Then you have to do the swab sampling. And how to do the swab sampling? You have to determine certain surface area, take a swab, and the solution which is used for the swabbing will be the solution in which the product is soluble, and that comes from the development data, that comes from product development data, that which is the solvent or which is the most effective solvent to clean the product. It can be water for injection, it can be another solvent. So take the swab, take a sample and put it back again, and you give it for the testing to QC. And what should be the limit? Limit will be based on the total surface area of the vessel which is used and the concentration, which is like maximum allowed concentration. So basis that we have to calculate, like we have to consider total surface area, maximum allowed carryover we have to calculate based on the surface area, product dose of the previous product, dose of the next product. Considering, and there is a specific equation which is I have displayed on the screen, so you can use that equation to determine the maximum allowable carryover value. And the rinse sample and swab samples should have that concentration, the traces below that maximum allowable carryover. If the traces are below that, means your cycle is good and it's cleaning the product. But if traces are more, then you have to work on the CIP cycle again. You may have to have additional rinse steps, or you have to determine which specific location is failing in cleaning validation, and you have to determine how to effectively clean that specific part. You may have to have additional rinse, or you may have to dismantle certain parts and wash it separately. There are ways and methods to overcome, but this is the way you can validate the CIP cycle for your product. So hope this small video is helpful for you to understand how a CIP cycle can be validated. If you have questions, you can put in the comments, and I will try to answer those, or I can prepare more videos on that specific to answer the specific question. Thank you very much.